Greetings, ladies and gents. In this video, we will be looking at the energy extended practice question, which is the third one. So in this case, in the previous videos, we have been looking at the practice questions based on what we did in this case on energy. So in this case, this is the third question. Now, if you haven't watched the other ones, be sure to refer back to that. But in this case, for question 3, they say that a 5 kg block is released from rest from a height of 5 meter, and it slides down a frictionless incline to P, right, as shown below. It then moves along a frictionless horizontal portion, which is PQ, and finally moves up a second rough inclined plane. They say that it comes to stop 3 meter above the horizontal at point R there. So in this case, when our object reaches that point R there, it will simply have a speed of 0. So that's where in this case it will stop. So they say that in this case the frictional force, a non-conservative force between the surface and the block is 18 newtons. So in this case for 3.1, now what you must just notice that they in that statement they said that in this case between these 2 points, all right, let me just say between these points we do not actually have friction on those points there. So in this case, between those 2 points, between the starting point here, 2 point Q, we can actually use the mechanical energy formula if you want, right? But remember, we said that of course we can also use that that non-conservative formula, right? In this case, if we do not have actually the non-conservative forces, as we will simply just put a 0 there. But in this case, what I can simply just say is that if in this case you are if in this case your system, right, at a particular portion there is no friction, so what you can just simply do in this case would be just to use the mechanical energy. So that's only if in this case you do not have a frictional force acting on your object, and if you do not have tension, or in this case the applied force. So in this case, we notice that in this case this object there is simply sliding, right, by itself until it reaches in this case that point there, right, and of course until it reaches point R. So in this case they said that using energy principles only, calculate the speed of the block at a point in this case P. Now remember that of course between these 2 points we do not actually have frictional force there. So in this case, let me just bring our energy principles. So in this case, these are our energy principles that we have. So in this case, since we do not have friction, no applied force or even tension, so in this case what we can simply just do would be to use the mechanical energy, which says in this case the mechanical energy at point in this case, let me just put this point to be point let's say point A there. So in this case the mechanical energy at point A would simply be in this case equal to the mechanical energy at point P there. So in this case what I can simply just do would be to expand that. We know that of course the mechanical energy is simply equal to in this case to the potential energy of the object plus the kinetic energy. I'm sure you know that. So in this case this will simply be in this case mgh at point A plus in this case half mv squared at point A, being equal to the same thing but in this case at point P, which is mgh at point P plus mg plus in this case plus half mv squared at point P there. So in this case what we can just simply do there would be to substitute our values. So in this case the mass of the object is 5, all right. In this case we know that of course g is 9.8, then our height when that object is at point A is simply that 5 there. So in this case we say plus. So in this case what you can just simply do would be to put a 0 there for this portion. Why? Because in this case when our object is at that point, they told us in this case that that object was released from rest. So in this case as soon as the velocity there is 0, so in this case that makes that whole thing there to be 0. So in this case simply be equal to, so in this case even on this portion I think we can also just put a 0 there. Why? Because in this case remember that when this object is at that point, the height in this case would be 0. So anything multiplied by 0 is simply a 0 there. So it simply be plus a half multiplied by the mass, which is that 5 in this case multiplied by the P in this case squared. So in this case what we can just simply do, if you put this into a calculator, what you're simply going to get would be in this case 245 right, being equal to, in this case, if you, of course, a half of 5, that's actually 2.5 v, so that's vp squared, and you take in this case this, so divide by 2.5 on both sides. So in this case what you're simply going to have would be, in this case, 98, right, being equal to, in this case, v p squared. So in this case you take in this case the square root on both sides. So in this case, if you do that and put that into your calculator, what you're simply going to get is your speed at point P would be, in this case, 9.90 meters per second. So in this case that would be, in this case, for 3.1. So in this case for 3.2, they said that explain why the kinetic energy at point P is the same as that at point Q. So they're asking us this case to explain why, in this case, the kinetic energy of the object at this point is equal to the kinetic energy of that same object when it reaches point Q. And the reason for that is simply it's very simple. We know that, of course, between these 2 points there is no frictional force there. So in this case there is no force that is actually causing the object to lose its speed nor to gain more speed. So in this case we can say that's because there are no external forces acting on the block between point, in this case, P to Q, or you can say it's because there are no non-conservative forces, right, acting on the object between point P to Q, which would be a nice reasonable reason there. So in this case for 3.3, they said that explain the term non-conservative force. Now I'm not going to write that down, unfortunately, but in this case a non-conservative force is a force whose work done in moving an object between 2 points depends on the path taken. So that's the formal definition there for non-conservative force. So in this case for 3.4, they said that calculate the angle theta, right, of the slope QR. So in this case what we are simply going to do now, it's not going to be easy to calculate that theta. There's not going to be straightforward. Why? But in this case what we must just simply notice that in this case, as our object is actually traveling, right, as it is sliding up that incline until to point R, so in this case the only force that is actually acting on that object would simply be the frictional force, right? The only in this case non-conservative force that would be acting on that object would be, in this case, the frictional force. So in this case what we can do is that, now remember in this case that we have three energy principles, which is of course this one, that one, and that one there. But in this case we cannot actually use this principle there. Why? Because in this case we have between those point QR, we actually have there a non-conservative force. So as soon as we have those non-conservative forces, we can use, or we cannot use this mechanical energy there. But in this case the only two that we now left with would be these two there. But in this case what you must just simply note is that if you look at the information that we have on that portion, we actually have the vertical height there, and the only equation that is left that actually includes a vertical height is actually this non-conservative force there. So in this case you're going to neglect it, this, right, and use that one. So in this case what we are going to have would be, let me just erase that. So in this case you're going to use the non-conservative force, so this will be WNC equal to the change in the object's kinetic energy plus its change in potential energy. So in this case, remember that the only non-conservative force that we have as this object is traveling between point P to between point Q to R is only the frictional force. So in this case simply be the work done by, in this case, by Fk. That would simply be equal to in this case simply be half mv squared. Let me just leave that as it is. So in this case simply be delta Ek plus, in this case, delta Ep. So in this case if we expand this, what we can just simply do, now remember to calculate work, we say that's actually work simply be, so this simply be equal to Fk, right, multiplied by delta x multiplied by cos of theta being equals to, in this case, the change in the object's kinetic energy. So it's final minus initial, so it's simply be, in this case, a half at mv squared at 8 at point R. This is minus half mv squared at point Q. So this is simply be plus mgh at point the final at point R minus in this case mgh at point at that point Q. Now what you must just note is that these two are simply going to give us in this case 0. These two here. Why? Because in this case, when this object reaches that point, the speed of the object, they told us in this case that this object actually stopped right when it reached that point R there. I think they said that somewhere in that statement there. I don't remember actually that where, but in this case, I'm sure I read that. So in this case, what we can just simply do there would be to say. So in this case, what you simply do would be to say that in this case, so in this case for these two, we're simply going to put a bunch of zeros there. So in this case, what we have, so they actually gave us in this case the kinetic frictional force to be 18. So in this case, simply be in this case 18 multiplied by in this case by delta x. Now remember that we do not know in this case how far this object was displaced between point P, between point Q and R. So in this case, that's what we are actually trying to find there. So in this case, after we find that displacement there, you would notice that in this case, this is actually type of a triangle that we have there. We would actually have in this case the opposite, which would be 3. We would actually have also this, right? In this case, the only thing that would be looking for in this case would be that angle there. So in this case, what we are simply going to do would be to say, so it would be multiplied by cos of, now remember that in this case, our object is being displaced up, all right? So in this case, in that direction, but in this case, our the direction of the frictional force would be in this case downwards. So that's Fk. So in this case, the angle between these two would simply be 180. So it's be cos of 180 degrees being equals to a half. Now again, remember what I said, this is actually going to give us a 0 there. So simply be 0, right? In this case, 0 plus minus a half multiplied by, so the mass, that's actually 5 multiplied by in this case the speed of the object at point Q, which we found to be 9 so in this case we know that. So in this case, remember that of course, as this object is traveling between these 2 points, in this case the speed doesn't change, it's the same. So in this case, that simply means that in this case the speed of the object at point P would be in this case the same speed, so in this case the object actually have the same speed when it reaches that point Q there. So in this case at point Q, would know that of course that the speed is simply 9.90 square that plus the mass, which is 5 multiplied by 9.8 multiplied by the vertical height at point R, which is a 3. So in this case, remember that's going to be minus 0 there, right? So in this case, if you put this, right, this entire thing here in your calculator, what you're simply going to get would be negative 98.025. So in this case, simply be, now if you put cos of 180, that's actually negative 1. Negative 1 multiplied by 18, that's going to be negative 18 multiplied by delta x. So what you're going to do would be to divide by in this case by negative 18 on both sides, and what you're simply going to get is a delta x would actually be in this case 5.445, right, 833, and so on and so forth. Now we can't round that off. Why? Because in this case, remember, we are trying to look for that angle theta there, not the displacement. So in this case, what we are simply going to do now is that, now if you look at that triangle there, which is that so in this case, which is this triangle there. So in this case, we have R there, we have and this is Q. So in this case, now we actually know this length, which is that 5.4458 blah blah blah, and in this case we are looking for theta, and in this case we actually have that opposite there to be in this case 3. So in this case, what we can just simply do there would be to use in this case our trig ratios, specifically the sine trig ratio. Why? Because in this case we have the opposite, and we also have in this case the hypotenuse. So in this case, what we are simply going to say would be sine of theta would simply be equal to the opposite divided by the hypotenuse, which is 5.44, that's actually 5, and so on and so forth, right? So in this case, so to find theta, this is what you're simply going to do would be to say so you would say shift sine, and you would put this ratio that you have there. So simply be in this case sine arcsine, right? This is 3 divided by 5.44 53 and so on and so forth. So in this case, if you put that into your calculator, what you're simply going to get is your theta would be that so your theta will simply be in this case 37.14 degrees. So that will simply be in this case your theta. So in this case, this is the end for this question. I don't think there's more question down there. So in this case, we actually have a final one that we are going to do in the next video. So if you haven't subscribed, be sure to subscribe and hit that notification bell so that when the next video comes up, you will be the first to be notified. So otherwise, if this video helped you to some extent, be sure to leave a like. But otherwise, ladies and gentlemen, as the story always ends,